If your Python code is full of repeated blocks, small changes can quickly become painful. In this video, we'll take 10 real examples and turn messy code into clean, reusable functions you can use in actual projects. We start with the simplest useful function pattern. Take input values, build a result, and return it. Imagine a small admin script that prints user profiles in the terminal. Instead of writing the same string format again and again, let's write a function that receives the username and role, then returns the final text. Now we run the script and check that every user is printed in the same clean format. Let's break down why this works. The function does one job. It receives two pieces of data and builds a string from them. Because it returns the string, the rest of the program can decide whether to print it, save it, log it, or send it somewhere else. Now let's show the best practice. Keep this function focused on formatting and return the value instead of printing inside it. Use this approach when the same formatted result may be needed in more than one place. For a quick practice variation, add a department argument. Your goal is to produce a line like Alice, admin, engineering, using the same function style. Next, we move repeated business calculations into a function so the same rules are applied consistently. In an e-commerce backend, order totals must be calculated the same way every time. Let's put the price, quantity, tax, and discount rules inside one function so each order uses the same logic. Now we run it with 3 different orders and look at the final totals. Let's unpack the result. The function first multiplies price by quantity, then subtracts the discount, then applies tax to the discounted amount. The caller only receives the final rounded number, which keeps the loop very simple. Now let's show the best practice. Keep this calculation as a pure function. That means the same inputs always produce the same result, with no hidden database calls, prints, or global state mixed in. For practice, extend the function with shipping cost. Decide whether shipping should be added before or after tax, then make that rule clear in the function. Now we use functions to keep validation rules readable and reusable. Before creating an account, real projects need to reject bad sign-up data early. Let's write a function that checks 2 simple rules. The email must contain an @ sign, and the password must be at least 8 characters long. Now we run the sample attempts and see which ones pass. Let's break down the output. Alice is accepted because both rules are true. Mark is rejected because the email is missing the @ sign, and Nina is rejected because the password is too short. Now let's show the best practice. Give validation rules a clear function name. When the main code reads is valid sign-up, the intent is obvious without forcing someone to decode several conditions in line. For a small variation, add one more rule. Reject passwords that contain the word password. Keep that rule inside the validation function, not in the loop. Now we parse raw text into structured values before the rest of the program uses it. Config files often store values as plain text, like timeout equals 30. Let's write a function that converts each raw line into a clean key and value pair. Now we run it and confirm that extra spaces are removed before printing. Let's break down the parsing step. Split with a limit of 1 means only the first equals sign separates the key from the value. Strip removes spaces around both pieces, so env with spaces still becomes a clean key. Now let's show the best practice. Normalize raw text as soon as it enters your program. After this function returns, the rest of the code can work with clean values instead of worrying about spaces and separators. For practice, make the parser stricter. If a line has no equal sign, raise a value error with a message that explains which line was invalid. Finally, in this batch, we build a utility function that solves a common naming problem. When a title becomes a file name, spaces, punctuation, and uppercase letters can cause messy results. Let's write a slugify function that turns a title into a lowercase hyphen separated string. Now we run it with a few real-looking titles and check the generated file names. Let's explain the transformation. The function lowercases the title, keeps only letters and numbers, and turns spaces, hyphens, and underscores into one standard separator. The final split and join remove duplicate or leading hyphens, which is why the file names look clean. Now let's show the best practice. Make utility functions deterministic. If the same title comes in tomorrow, this function should return exactly the same file name, which makes caching, testing, and debugging much easier. For a practical variation, add a length limit. Try keeping the slug under 40 characters, and make sure the final file name does not end with a hyphen. Now we move into functions that work with collections because real project data usually comes in lists, dictionaries, and API-style records. Dashboards and reports often need a quick summary from API records. Here we write summarize OSH orders, pass in a list of order dictionaries, calculate the count and revenue, then run the script and look at the summary. Let's break down the result. The list has 4 dictionaries, so total orders is 4, and the revenue is the sum of every amount value. Returning a dictionary keeps the summary easy to print, test, or send to another part of the program. The best practice here is to pass the orders into the function explicitly. That makes the function reusable with real API responses, test data, or filtered data, without depending on a global variable hidden somewhere else. Next, we make function calls easier to read and easier to customize with default and keyword arguments. Notification functions are a good place for defaults, because most messages use the same channel and priority. We create send notification with default values, call it once with no optional settings, then override the parts we care about and run the script. Let's unpack the output. The first message uses email and normal priority because we did not pass those arguments. The second and third calls show that we can customize one or both optional values without changing the function body. The best practice is to use keyword arguments for optional settings. A call like priority equals high is much easier to understand than a random second or third positional string. Now we treat functions as values, which lets us customize behavior without rewriting the same loop again and again. Projects often filter users, orders, or logs with rules that change over time. Here we write one filter to sort items function, then pass in named predicate functions for active users and high-value orders. And now we run it to compare both results. Let's look at why this is useful. Filtered on items only handles the loop, and each predicate handles one business rule. That separation lets us reuse the same filtering logic for different data. The best practice is to use small named predicate functions when the rule matters. Names like is active like user and is high value order make the code read like the actual requirement. The next pattern is about writing functions that handle messy input in a controlled way. Ordered CSV values and API fields are often strings, blanks, or missing values. Here we write safe int, so valid numbers convert normally, bad values return a clear fallback, and then we run the script against messy input. Let's break down the behavior. Strings like 42 and 7 can become integers, but an empty string, n/a, and none cannot. Instead of crashing, the function catches those specific conversion errors and returns -1. The best practice is to catch specific exceptions and use a fallback only when that fallback is part of the design. That way, real programming errors do not get hidden by an overly broad except block. Finally, we add a production-style utility, a decorator that wraps another function and measures how long it takes. In real projects, we often want timing information without adding stopwatch code inside every function. Here we build a timed decorator, wrap a slow processing function, then run the script to see both the timing line and the original result. Let's explain what happened. The decorator replaces process just records with wrapper, but wrapper still calls the original function inside. That gives us one reusable place to measure time and still return the normal function result. The best practice here is to use functools.wraps inside the decorator. It keeps the wrapped function's name and metadata intact, which helps with debugging, logs, tests, and documentation tools. You've just seen how Python functions make code cleaner, easier to test, and easier to reuse. If this helped, like the video, subscribe to Dev Level Up, and comment what Python topic or real-world example you want next.